Let's look at the next type of sorting algorithm, which is called insertion sort. Now, in insertion sort, uh, what is done is in each pass, the element is inserted into its correct position. When you want to sort given set of numbers, each position after sorting would belong to a specific position, right? So, what is done in insertion sort is every pass you go through the array, you put one number into its correct position. So if I'm going through the array for the first time, first number will put in correct position. I'm going to the second time, second number will put in its correct position. So you pick up the number and make sure by the end of the pass that number is put into the position where it actually belongs. Right? So let's see how it is actually written. So we've taken this as an example array. This set, this is the position number, and this is the value at that position. So we've taken a set of six numbers. So we start by comparing the second number. Okay. So because we want to start moving the numbers towards left, and we want to sort in ascending order. Right? So we take the second number and compare it with the first number. Now, if we want in ascending order, this has to come before 10. So we move 2 ahead, 2 in the place of 10, and 10 is more in place of 2. Now, in between these two elements, it is sorted, right? If you consider only this as a sub array, they have been sorted properly, and 2 has been inserted into its correct position for this sub array. Right? Now we'll move to the next index, right? This is not required. You can remove this. Move to the next index. We'll consider 42. Now, if you consider 42 and I compare it with 10, 42 is already greater than 10, and we know these two are sorted, so there is no need to compare 42 and 2 again. So if 42 is greater than 10, 42 will be greater than 2 also, because in the previous pass we've ensured that these two are in the sorted place. Fine. So once I compare these two, I realize nothing has to be changed, so we'll leave it as it is. So in the pass 2, nothing happens, the array remains as it is. Next, we move to the next index. We look at this number 22. And 22 is compared with 42. 22 is smaller, so we'll move 22 behind and move 42 in its place. Compare 22 with 10. 22 is bigger, so there's no need to move 22 any further. And because we know this is already sorted, there's nothing to do. Fine. So now, once we have come till here, that means this sub array is sorted. We don't know about these two elements, but these four elements are sorted properly. Fine. Next, we move to the next element, which is the number 60. If you consider 60 and compare it with 42, it's already bigger than 42, so nothing to change. So this subarray is sorted properly. Next, we move to 30. Now look at 30 and compare it with 60. 30 is smaller, so move 30 to the left, move 60 to the right. Compare 32 with 42. 30 is still smaller. Move 32 to the right, 42 to the left. Compare 30 with 22. 22 is smaller than 30, so there's no need to move it any further towards the left. And no need to compare 30 with 10, because we know that once it is less than greater than this number, it will be greater than this and this also. Right? So that 30 has reached its correct position. So now the whole array is in the sorted order. So we can see what we do here is we can, in the past numbers have been extra. You can So each time we go through the elements, we make sure that whichever element we are considering, that element is moved to its correct position with respect to the numbers that we have seen till now. So if I look at this and this, 2 is moved to correct position here. Then when I come to 42, with respect to 42, the numbers behind it are properly sorted. When it comes to 22, I move 22 so that it reaches correct position with respect to the subarray that is there behind it. So as we keep moving each number to its correct position, when we reach the last number and we move this number to correct position, everything else will also be in the correct position, right? That's what insertion sort is all about. So in the algorithm, what we'll do, we'll start from here and start comparing the number with its previous number and stop comparing either if we reach the zeroth index or if we reach an element where the element being considered is greater than the element that is being compared with. So for example, here I start from here, I start comparing with the previous number. It's already bigger, so I don't need to do anything. I leave it at this. Look at this 22 and 42 are compared. 22 is smaller, so I move 22 behind and I have not reached the zeroth index, so I compare 22 and 10. But 22 is bigger than 10, so I stop here. So either I reach the first index here, index 0, or I reach a stage where there's no need to move the number further. So one of these two conditions I'll stop in each pass. Like that, I will repeat the passes for all the numbers n minus 1 times. Fine. So there are six numbers. I did 5 passes. So the six numbers are there. We did 5 passes to identify the correct so sorted array. Fine. So let's put it into a program and see how it works. So we start with for I range of we start from 1 instead of 0 index. We start from 1 index and we go till the full length. So we take the first element into a temporary variable called val and we start comparison with one element behind the element we are considering. So we're considering the ith element. We start the comparison with I minus 1 element and we repeat till the either we reach the beginning of the index till the zeroth index or we reach a stage where the number that is being compared and the number that we are currently considering is lesser than that. So val is less than whatever item we are considering in the list in the pass. Fine. So if it is not lesser, we move it towards the right. So this element moves towards the one index higher. Fine. So if we compare this with this state, I'm considering 22. 22 is less than 42, so I move 42 to its next position. So that's what is being done here. Item list of temp. So for example, here temp would be this index 0, 1, 2. So second index value goes to third index value. Temp would be 2. It is moved to index number 3. And you reduce the index value by 1. So you move one more element behind. So keep repeating this till either you reach the beginning index or you reach a stage where the element is already greater than the previous element. Then you stop it here. And once you have stopped, so whatever value that we're actually considering, that has to be put to its correct position. Right? So for that, for example, here we are considering 30. 30 has to be put here in this correct position. We were moving 60 towards the right, 42 towards the right. Once we realize that there's no further need to move, 30 has to be put to the correct position. That is being done here. Val is equal to item list temp plus 1. So wherever we have stopped moving, put the element one element after it. So we have moved stop moving here. So put the element 30 after this. Right. So this is the sample array we are considering. Call the insertion sort and print the sorted array. So you can see what happens here. The sorted array gets printed here. Right. So this is the element that we considered array, and this is the actual sorted list that we got after the insertion sort. Fine. So only thing you have to remember is every time we go through this loop, you identify where this should fit in, and once we exit this loop, we put the value into its correct position wherever it is belonging, either at the index 0 if we came out with temp being equal to 0, or at index value wherever this condition got satisfied, wherever the value became greater than the item in the list. After that element you put it. So here 30 became greater than 22 here, so you put the value after 22. So that is 10 plus 1, right? So that's what insertion sort is all about. The algorithm is clear. Thank you.